Okay, boys and girls, this is going to be your intro to quadratics. So then tomorrow during class, we can just get to work on what we need to do. So if you look at the graph, the quadratics are very similar to our absolute value functions, except here at the bottom, it's more of a curve than a sharp turn and a point. But that's basically the only difference in the looking of the graph. This right here would be your parent function. This is the most basic form of it. So our vertex down here is right at 0, 0, because that's what our parent function does. So this is our parent function. Okay. First thing we're going to go over is the shifts of this graph. It is extremely similar to our absolute values that we did last unit. So our absolute value would look like this, where this was the vertical stretch. This was the horizontal shift. And this was the vertical shift. Don't forget that the horizontal is the opposite. So this was very similar, because if I write the other one for quadratics, it looks like this. So everything's the same. The only thing that actually changes is, instead of it being an absolute value function, it is now a function that I'm squaring. So that is the only change from here to there. Everything else means the exact same thing. And of course, if there was a negative here, that means the graph would be flipped upside down. So that's one piece of information that you should know already. Okay. Now, if we remember, this is also called vertex form. So with our parent function, there's no other numbers, there's no shifts going on. So if I had to put numbers in, it would be 0 and 0, and that's why the vertex is at 0, 0. Okay, so with vertex form, there's also another form that you're going to see a lot, and that is called standard form. So in standard form, y equals ax squared plus bx plus c. Standard form. Okay, so remember, the a and the x and the b and the x, they're not related. They're not together. There's multiplication in between, and there's something different. The x and the y are going to represent some point on this graph, any point on the graph. And the only thing you're squaring is the x. You're not squaring the a. So just remember, standard form, ax squared plus bx plus c. Now, we're going to work on going back and forth between these forms. Each form tells us something different. We can find out different pieces of information that can help us graph this and help us find critical points that can tell us information in word problems. So if I were to draw a graph here, let's say I draw one at, what is this, -4, because they go up by 2. And this is -6. And then 2, 3, 4. And then 2, 1, 2, 3, 4, right? 2, 3, 4. I'm trying to figure out how to graph these here with the scale. So if I go 1 over, I should go 2 up. There we go. 1 over, 2 up. If I go 2 over, I should go 1, 2, 3, 4, 5, 6, 7 up. 1, 2, 1, 2, 3, 4, 5, 6, 7 up. Okay, that's where that one should go. 1 over and 1, 2, 3, 4, 5, 6, 7 up. Boom. Oh, that should be over here somewhere. Okay, there we go. So now I graph this one. If I did this in vertex form, it would be y equals x, because I went over this way, plus 4. And then, because this is the opposite, then I go up 6, and then that's squared. So that's this in vertex form. Now I want to change this to standard form. So now in standard form, you have to multiply all this out, which means this is not x squared plus 16. Oh no. We're going to make sure we remember that something squared is something times itself. You're going to see this so much this unit. You have to do it this way. So now if I distribute to both terms, I get x squared plus 4x, another 4x, and a 16. If I combine, and don't forget this x, then combine your like terms, x squared plus 8x plus 22. Okay, so if I graph this, it should look very similar to this over here. So let's see. Let's see if this works. Highlight it, hit math. That's what I want. I want to graph in 2D. Okay, let's zoom in so the scale is the same. So I go to -20. Then the highest I go is 30 over here. It's a little extra. So that looks close to the same. Actually, it's more zoomed this way, right? Okay, so that looks pretty good. So I'm gonna insert on page. Okay, now it's down here. So now, this graph and the purple one look pretty close to the same. That's what I'm talking about. So now there's key features in this graph that you can see here. One of them is you can see the y-intercept, which is right there. So if these count by 2s, and this is 10, 12, 14, 16, 18, 20, 22. There's the y-intercept, and I have the same thing right there. So that is one part that you can find key information from this graph. So tomorrow in class, we're going to be working on going from vertex form to standard form. We're going to be working on graphing when I give you a vertex form and see if you can multiply this out and get it into standard form. That will be your little introduction to quadratics, and then we'll talk about other key features tomorrow. All right, boys and girls, see everybody then.